Welcome to lesson 2.4 on multiplying and dividing radical expressions. So let's just dive right in. Products of binomial expressions involving radicals may be expanded using the distributive property and the multiplication property of radicals, just like what we were using before. The nth root of a times the nth root of b equals the nth root of ab. So let's go ahead and start doing some examples. Example 1. Expand and simplify. So we're going to use our distributive property. Our distributive property is we take the first term of the first binomial, 3 root 2, and multiply it by the entire second binomial, as so. And then we keep the sign, and we use the second term of the first binomial and multiply it by the second binomial as well. Then from here, we distribute again. We go 3 root 2 times 5 root 2. Using our multiplication rule, we know that it's 15, and root 2 times root 2 just becomes 2. Because when you multiply your square root by the same square root, it becomes just the value. And then subtract 3 root 2 times root 15. 3 times 1 is 3, and root 2 times root 5 becomes root 10. Alright. 4 root 5 times 5 root 2 becomes 4 times 5 is 20. 5 times 2 is root 10. And 4 root 5 times root 5 is negative 4 times 5. Simplifying, we get 15 times 2 is 30, minus 3 root 10, plus 20 root 10, minus 4 times 5 is 20. Collecting like terms, we get 30 minus 20 is 10, and minus 3 root 10 plus 20 root 10 is plus 17 root 10. And that is our most simplified version. Alright, let's do another one. B. 4 root 3 plus 2 root 6 times 4 root 3 minus 2 root 6. Well, if you notice right away here, we're going to be squaring the two terms separately. So when we go and distribute, we get 4 root 3 onto 4 root 3 minus 2 root 6, and we get plus 2 root 6 onto 4 root 3 minus 2 root 6. So go ahead and continue. We're going to get 16 times 3 minus 8 root 18 plus 8 root 18 minus 4 times 6. Our middle terms here are going to just cancel out nicely because it's a perfect square. So we're going to continue and get 16 times 3 minus 4 times 6, which simplifies to 48 minus 24, and we have a final answer of 24. Let's move on. The strategies used to expand and simplify products of binomial expressions can be extended to include radicals with variables in the radicand. It is important to identify the values of the variables for which the expression is defined. So before we're going ahead and solve an equation or expression, we need to define the variables of that. So, for example, identify the values of the variables for which each expression is defined, and then expand and simplify. So in this expression, we have root y. For what values of y is this expression defined? Well, in a square root, y has to be greater than or equal to 0. Let's go ahead and solve it now. Using our distributive property, we have 8 onto 5 plus 2 root y. And then we have 3 root y to 5 plus 2 root y. And we get 8 times 5 is 40. 8 times 2 root y is 16 root y, plus 3 root y times 5 is 15 root y, and 3 root y times 2 root y is 6 times y. So finally we get 40. Collecting like terms, we get 31 root y, and 6y becomes 6y. We cannot simplify any more from there, so this is our final answer, our most simplest expression. All right, try another one. Here we have two variables, root x and root y. So for what values are these variables defined? X and y both have to be greater than or equal to 0 in this case. Going ahead, we have 5 root x onto 7 root x minus root y plus root y onto 7 root x minus root y. And here we have a square, so we can write that as root x plus 4 root y times root x plus 4 root y. We'll distribute that out as well. Going along, we get 35 times x minus 5 root xy plus 7 root xy minus y minus, let's put that in a large parentheses, root x times root x plus 4 root y plus 4 root y onto root x plus 4 root y. Going ahead and simplify more, we get 35x. Collecting like terms, we get plus 2 root xy here, minus a y. Simplifying this, we get x plus 4 root xy plus 4 root xy plus 16y. Now we got to distribute that negative there, so we get all this remains the same, and we get negative x minus 8x root xy when we collect like terms, minus 16y. Collecting like terms again to simplify, we have 34x from that, and we get negative 17y from that and that, which leaves us with negative 6 root xy. And that is our final answer there. Woo, that was a big one. Alright, what do we have next? Simplifying a quotient with a radical expression in the denominator involves rationalizing the denominator and then simplifying the numerator. Alright, let's do an example. So here we have 1 divided by root 2. We want to get rid of that root 2 on the bottom of that fraction there. So we're going to rationalize by multiplying the top and the bottom by root 2. This will give us 1 times root 2 as a numerator and root 2 times root 2 as a denominator. 1 times root 2 simplifies just to root 2. And root 2 times root 2 gives us just 2. This is equivalent to 1 over root 2. We did that by rationalizing. So when we come up to questions that have new denominators with a radical, we want to go ahead and rationalize that to simplify. Alright, example 3. Simplify. Here is our first case. 3 root 5 plus 6 divided by root 3. So we need to rationalize first. So we're going to multiply the top and the bottom by root 3. This will give us 3 root 5 times root 3 plus 6 times root 3, all divided by root 3 times root 3. That simplifies to 3 times root 15 now, plus 6 root 3 divided by 3. And we can simplify that even more because we have a common factor here. And this becomes root 15 plus 2 root 3. And that's our final answer. Let's try another one. If you'd like, you can take this time to pause and go ahead and try working it through on your own. Yet again, we need to rationalize. Root 11 will give us 2 root 7 times root 11 minus root 3 times root 11, all divided by root 11 times root 11. Simplifies out to 2 times root 77 minus root 33, all divided by 11. We have no common factors here, so that is our final answer for that question. Okay. When the denominator of a quotient of the radicals is a binomial, use a difference of squares to rationalize the denominator. So, instead of multiplying by itself, now we want to use a difference of squares, which means we need to multiply by the opposite binomial. So, we'll multiply root 2 minus root 3 to the numerator and the denominator. And that is a difference of squares. That will become root 7 times root 2 minus root 7 times root 3, all divided by root 2 onto root 2 minus root 3 plus root 3 onto root 2 minus root 3. Simplifies to root 14 minus root 21 divided by 2 minus root 6 plus root 6 minus 3. And our root 6's here are going to cancel out nicely, and hence we're left with root 14 minus root 21 divided by 2 minus 3, or root 14 minus root 21 all over -1, leaving us with no radical on the denominator. Hence, the binomial root 2 minus root 3 is the conjugate of the binomial root 2 plus root 3. So to rationalize the denominator of a binomial, we multiply by the conjugate. Alright, let's do some examples with that. Example 4. Simplify. 4 plus 2 root 5 divided by 3 root 2 minus 4. So, we need to rationalize by multiplying by the conjugate. The conjugate here is 3 root 2 plus 4. And we do that to the numerator and the denominator, right? That will give us, let's use our distributive property, 4 times 3 root 2 plus 4 plus 2 root 5 times 3 root 2 plus 4. And our numerator will be 3 root 2 times 3 root 2 plus 4 minus 4 times 3 root 2 plus 4. Simplifying will become 12 root 2 plus 16 plus 6 root 10 plus 8 root 5 divided by 9 times 2 plus 12 root 2 minus 12 root 2 minus 16. Simplifies to 12 root 2 plus 16 plus 6 root 10 plus 8 root 5 all remains the same, nothing to simplify there. But on our denominator, we can cancel out our 12 root 2's, and we're left with 18, 9 times 2, minus 16, which simplifies to 12 root 2 plus 16 plus 6 root 10 plus 8 root 5, all divided by 2, which is a common factor here. So our final answer will be 6 root 2 plus 8 plus 3 root 10 plus 4 root 5.